days of days. Pseudoscience just a big charade. Making theories they just can't explain. On philosophically biased claims. Days of days, we break away just like a renegade. So pay attention, gonna get a grade. We're schooling globals till they all awake. Schooling globals with diplomas and a chip on the shoulder. Debate is over, mind is sober, solar system disclosure. Can't go back once you heard the facts. You make a pact, never take the backs. Schooling ballers and the followers that give them the dollars. They try to holler in the chat that you're a fraud, not a scholar. They hating y'all, that's why they attack. The earth is flat no matter how much they laugh. Days of days, pseudoscience just a big charade. Making theories they just can't explain. On philosophically biased claims. Days of days, we break away just like a renegade. So pay attention, gonna get a grade. We're schooling globals till they all awake.
In a world. What up? Welcome to Schooling Globers episode 9, Sunset. Hopefully everything looks and sounds good. Alright, so believe it or not, it is 2023 and we have to discuss sunsets on a flat earth. It appears that people still claim that is an impossibility. Very interesting indeed. So, we can of course just cover the basics here. We see the sun rise in the morning from the east. It then proceeds to go over our head and then it's directly overhead at noon. And it continues in an arc through the sky and it sets in the west. That is called a sunset. People seem to think that when we see the sun move in the sky, it's not actually moving. It's just an illusion. As is your perception that the earth is not moving. So it feels like you are still and stationary, but actually the earth is supposedly moving. So it looks like the sun is moving through the sky, but it's actually sitting still relative to the earth. And during the sunset, you are actually falling away backwards, away from the sun, and it makes it look like it's setting because it then goes behind the curve of a ball. There are people that claim that there is no way that you can have a sunset if the earth is flat. They say things cannot be obstructed over a flat surface. The sun would drastically change angular size if it was small and local over a flat earth. The sun would never go down and you would have daytime forever. You could never have the sun disappear from the bottom up if the earth were flat. So they claim that this debunks flat earth and sunsets are impossible. Well, this is the show where we school globers, and this is one of the first days of class topics. This is a basic elementary concept to understand, but it appears that not everyone can understand it. So let's pull this over here and show you a couple examples of how incredibly simple this is. And we are going to okay. See if we can get a good shot here. So if you look down the street, you will see street lights let's do it like this. Straight. Okay. Wild that we have to do this, but we apparently do. Okay. Okay. Now, if you look here, you'll see these streetlights look like they're going down in the distance. Now, these streetlights are all the same height. It looks like it's going down in the distance. That's a good one. This is just due to perspective. So all of these streetlights are actually the same height. But as you look down the street, you see that they look like they're going down. And the ground is going to look like it's starting to ramp up in the distance. This is due to perspective. So I know this is very basic, but we do got some good points in here for you guys. To tell people that think the Earth is a globe, and it surely should appease their longing to understand the sunset on a flat Earth. But there will assuredly be people that are so devoted to being anti anything but mainstream rhetoric that they will attack this. But there's not much you can do about it. Anyone that watches the stream and then says that sunsets are impossible on a flat Earth anyway, they were going to say that before the stream started. They're going to say that till the end of time, until they die. They're not going to ever accept or address any specific evidence. And the truth is not for those people. Okay, so when we look out over the land or over water, throughout the day we see the sun get lower and lower in the sky. Now, what's so interesting about this is just a fact. Now, people call it flurfspective. No, it's just perspective. And what's interesting is the globe also has to account for this effect. If the Earth is a spinning globe, that doesn't mean perspective ceases to exist. Right? So, explain to me which part of your globe explanation accounts for the optical declination of the sun due to perspective. But of course, the fact of the matter is that that addresses that point. The sun looks like it's going down because it's going further away. This is just a fact. And it's of no coincidence that it looks exactly like a sunset does. Now, let's address the main one that people... Okay, they also claim angular size change debunks flat Earth. That the sun would change angular size drastically throughout the day. Right? Now, what most ballers don't know, which is okay, like for example, Tim Pryor in the chat here, stop texting and listen. Just for once in your life, actually listen to the information. Instead of just blocking out the information in this vicious state of cognitive dissonance, where you're just trying to type your like played out, redundant, unoriginal rhetoric in your script. Listen. You're feverishly typing straw mans and your script. You are not listening. But I mean, they can't actually listen. But anyway. So what most ballers don't know, and this is schooling globers, is that in the globe model, the sun actually does change angular size throughout the day. That's right. According to the globe model, the sun does change angular size throughout the day. Well, that's a claim, and let me explain to the globers why. If you're on a sphere and you have the sun in the sky, where you're perceiving it is going to change distance because you're on a curved surface, right? So the sun's going to be further away if you're on one end of the curve, then you're going to get closer and then further away. So it does change angular size in the globe model day to day. This is the funniest part about that, though. Can any baller provide empirical measurements of the sun changing angular size, the 0.08 degrees that the model predicts? Now, I've heard a few excuses. One, oh, that's just too small to measure. No, it's not. We have optical devices that can certainly measure that angular size change. So where
Wissit, I sent you the clip of Tim Pryor claiming he went to Antarctica at the wrong time of year to see the 24 hours sun to your Telegram. Play it. Lol.
Yeah, that's funny. I will play it in a second. Thank you for being a miswit. All right. So, let's read these off real fast. Hey, Austin, it's not much, but hope it helps with the move, etc. Yeah, bless. Thank you, Retro Reister Gaming, for the super chat. Shout out to the legends on Rockfin as well. Fishhead, Montana. Good luck with your move. I know Yah has this, man. Thank you so much. Much love. Thank you for the tip on Rockfin. Run Boston Bear. Tim, if you aren't going to listen, you should at least super chat battle with me. I'll go first. Thank you for the $20 super chat, Run Boston Bear. All right. So this is the thing about this whole conversation. The people that believe in the globe, by the way, it's very difficult for me to remember not to look over here at my OBS, but to look right here at the camera. So I'm trying to work on it, but it just feels awkward still. But all right, so what's interesting about this whole situation is the ballers never have to provide evidence for anything that they say. So your model necessitates, based on geometry, that the sun will change angular size
Tim,
throughout the
if you aren't
day.
going to listen, you should at least super chat battle me. Smiley face. I'll go first.
The geometry of a sphere dictates that the sun changes angular size and then gets to above head, then changes angular size again. So it's going to be smaller, bigger, smaller. This has to happen geometrically if the Earth is a sphere. Does anyone have empirical evidence of this ever happening ever? A very specific amount of the sun has to change angular size, then get above head, then change again. Guess what? It doesn't exist. That evidence doesn't exist. This is a very basic day one geometric claim of the globe. It should. Where's it at?
I love when you serve up some death blows.
Thank you for the $20 super chat, Bobby R. It doesn't exist. So the irony of the sunset. So this is just one of these talking points that we'll get from these zealots in here. Never provide flat Earth evidence. The fact that the sun doesn't change angular size based on the geometric necessity predicted by the globe is direct evidence that the surface isn't curving. It's basic geometry. The irony. I think that people should talk about the sunset quickly, because if people refuse to make concessions about the sunset, they are gone. But we are going to talk about something that I think most people haven't discussed with specifics regarding the sunset. And I find it to be very interesting. So, let me find the screenshot. Here it is. Okay. Now, and we'll talk more in depth in the future about why things disappear from the bottom up in general. We'll have a show in the future about that. Let's come over here. Let me show you this. Here's a screenshot I took from Harvard. There it is. Okay. Now this is showing the diffraction limit, or diffraction line, based on changing aperture. Okay, now you see what happens. It begins to converge and merge in the middle if you change the aperture, thus changing the resolution limit. So whenever you start to lose resolvability, these circles here, they don't actually change position. They just begin to merge together because of diffraction and angular resolution. Now this is done at Harvard. It's been done at BYU. It's been done at all kinds of different universities. It's very specific experimentation that can be physically replicated 1,000,000 times. Denial of this shows that you are religious. In fact, the sunset verifies that the earth is flat. And we are going to get into that quickly in just a second. So what I've done is I've taken a few pictures. So give me just a second. I'm having to save these. Okay. Now, like I said, we'll get more into depth in this with why do things disappear from the bottom up in the future. Let's check this other screenshot out real quick. As explained below, diffraction limited resolution is defined by the Rayleigh criteria as the angular separation of 2-point sources when the maximum of each source lies in the first minimum of the diffraction pattern or the Airy disk of the other. All right, now let me show you this other image. So what I did was flip one of these images over so that we can compare it to a sunset. So let's see, this line right here will be our horizon, our optical limit in the distance. That gives us our vanishing point, the horizontal horizon. This line right here, hopefully you guys can see my mouse. Not possible, but this picture on the left, you see the line separating the two circles. You probably can't see my mouse. Okay, now as you change the aperture and due to the diffraction line changing the resolvability of the image, look what happens. It begins to merge together. So if you look very closely at that in the middle here, let's see if this matches what we see in any other situations. Because, let me explain this real quick. Things do in fact disappear bottom up over a flat surface. Again, it's super easy to stillman their current script because it's just like robotic repetition, void of good faith. Like true intellect, dare I say, is the ability to converse live time. So live in the moment, you're able to react and adapt to critically assess and think and respond and rebut with substantive specificity. Just repeating scripts at the beginning and the end, no matter what anyone says, with laugh emojis, not. Okay? So we always invite people. I'll let you guys come on if we have time. We invite people to come on and try and do that, but it seems that's not usually what people are interested in. So we have something called angular resolution limit to our eyes. It's roughly 0.02 degrees. Okay, that's where you can no longer resolve things. Well, when you can no longer resolve it, you can no longer see it. So it disappears. You have an angular resolution limit. Now, this is based on something called propagation and reception angles. And when these angles get smaller than 0.02 degrees for the human eye, for example, you can no longer make it out. Now, say you see a boat in the distance with your naked eye, you can't really see it anymore, but you pull out a zoom, you can see it. Well, you've changed the aperture, the optical zoom, the resolution limit, so you can see further and bring it back into view. That includes the bottom of it as it goes away and it looks like it's disappearing from the bottom up. And again, if you have to deny stuff like this, I feel bad for you. It's not really relevant. Only relevant for as long as flat Earth can be successfully censored. That's it. So just enjoy it, live it up, right? You can only pretend to have value in this conversation until it's allowed to be freely discussed fairly. That's why your voices are still considered kind of loud and annoying. But anyway, I digress. So, and we're going to cover this more in depth with the why things disappear bottom upstream. Okay, but long story short, say you have an angle coming out from your eye. I'm going to get the iPad thing working so I can draw for you guys. So you get the angle coming out from your eye, okay? And this is True Earth 101 stuff. If you've been looking into this for a few years and you still don't understand that sunsets objectively do work on a plane Earth, set this one out, bro. Set this one out. All right, so you have the angle. Now, you draw a line right through the middle of that angle. That is your eye level, your line of sight, your diffraction line, your diffraction limit. Okay? And so say you're looking at a boat that's 30 feet tall and you're 6 feet tall on the ocean and you're looking out. Well, the bottom of that boat is closer to the diffraction line, the middle slice through that angle of view in the top of the boat, right? So let's say you're 10 feet off the ocean floor or off the beach, and then the boat is 30 feet. Well, there's 20 feet above you and 10 feet below you. So the bottom is going to hit that diffraction line first. It's going to hit it first. And you're going to lose resolvability. It's going to look like it's disappearing from the bottom up. Yo, which Telegram do I follow for the fast? Today I got one of 2 16-ounce salt blends I'd ordered. Do you know if those are shipped separately? If I can expect the second one to follow? Thanks, blessings to you. Oh, it's going to read it. You should have got them all. I'm not sure. Can you just message me personally on Telegram so I can get your specifics and look up what's going on? It doesn't make a lot of sense.
Which DG channel do I follow for the fast? Today I got one of 2 16-ounces salt blends I'd ordered. Do you know if those are shipped separately / if I can expect the second one to follow? Thanks. Blessings to you and fam. Crush on.
Much love. Message me personally at #witzit on Telegram. We'll get it situated. And then check your email that you purchased through so that you can receive the private Telegram chat. All right. So, like I said, we'll get more into depth of this. I'll put a presentation together for why things disappear bottom up and angular resolution limit with specifics. But I want to make sure that we all kind of soak this in here. This is what it looks like on the left. So imagine the sun being the top circle on the left. As you change aperture and lose resolvability, you see they begin to merge together. And guess which part of that top circle is disappearing? The bottom of it. So this is disappearing from the bottom up. And if someone looks at this image and denies that that circle from the left is disappearing from the bottom up, they're just lying. So that's irrelevant. So we all can clearly see. Now this is, again, experimental replicated evidence. You change the aperture, the resolvability changes. These two circles do not change position at all, but they begin to change the way that they are perceived. Eventually, they merge into an entire circle. So now let's just draw a straight line from right below that bottom or that top circle to the left. You have the horizon, and that circle is the sun. Well, as you begin to change resolvability, because things get further and further away and the angle changes and eventually it loses resolvability and the bottom angles get beneath the resolvability first, you're going to see that circle disappearing from the bottom up. This is, therefore, objective that things disappear from the bottom up due to resolvability. This is just a fact. Okay? Now, I get that that's not good for certain narratives, but that doesn't matter. All right, now let's see it. Now, do we see this in reality, though? Right? I mean, nah, that can't be the case. No, sunsets have to debunk letter. So let's come over here. All right, so again, of course, we see it go down. This is exactly like what we see the sun do. Oh, what a coincidence. It's exactly what we see the sun do in the sky. It's exactly what we see the sun do. Okay, so this is just a fact. Right, so this is the same thing we see the sun do. Okay, so now I want to re-look at this image. Look carefully again at the circle on the left. Now look at the circle in the middle as it's losing resolvability and the aperture changes. See what happens to that circle. Now, let's check this out. Wait a minute. Wait a minute. That does look very familiar. Oh, look at that. It's like the same thing or something. Now, believe it or not, guys, in this image here that was done by Harvard University, there's not a curved Earth in the picture. Okay. Now look at that middle picture, and I want to replicate this and do it with like really slow stills, or find like the best ones, and we'll get more into it. I'll refine this more in the future, but I find this to be very profound but simple. So as you see again, look at you see the bottom, it's kind of melting into where that horizon would be right here. To the left, you know, look in the middle, it's melting into it. Okay. Now let's just watch this video and really think about this image. And maybe what I'll do is actually, I'll just keep the image up here. Okay, let's check it out. Yo, and think about this. Think about the amount of cognitive dissonance that has to go on here. Sunsets work perfectly on a globe, simple in the real world, no need for complicated explanations. So don't even address the direct and inevitable refutation of the claim that sunsets are impossible on a flat Earth. Completely ignore it at all costs, and then just reassert that you think it's simpler on the globe, therefore it's true. Of course, it's ridiculous and antithetical to common sense on the globe because, again, they say the sun's not actually moving. During the sunset, you're falling backwards away from the sun. Wait, let's talk about it works perfectly and it's simpler and easy to understand. No reason for complicated explanations on the globe. Let's talk about it. Okay, the sun supposedly moves in the sky, but it's just an optical illusion. We feel like we're stationary, but that's just an illusion because we're spinning, but we're so big we can't tell. The sun looks like it's moving because we're moving, but we don't feel like we're moving, but it looks like the sun is moving, but it's actually not moving. It's just an illusion. And then whenever it begins to set, we're falling backwards away from the sun, as we are also taking an epic nosedive in the morning towards the sun. Please listen. So now we're looking at the sun go away from us in the distance, drop optically just like streetlights do, which is objectively a product of perspective. Okay, so then what? No, actually, it's physically dropping due to us falling away from it, and then at the sunset, we fall back, and then it goes behind the curve of the Earth. This is the official globe position. But actually, when we see the sun doing that, the sun is no longer there. It's actually already below the Earth, and it looks like it's still up above the horizon setting, but it's actually not there at all. It's a complete illusion. It's down beneath the Earth, and it's lifted up due to refraction. The entire sun is lifted up from 93 million miles away, and it's lifted up to look like it's still there, even though it should be dark and it should be down below the horizon. Oh, wow, such a simple... Now let's talk about the flat Earth position. The sun moves away from you. That's why you see it move away from you. Eventually, it gets too far away to see. As it hits the limit of how far you can see, it begins to disappear at that limit, which is at the bottom up. Oh man, oh wow. Like actual, real, physical, tangible experiments that can verify and prove that very phenomenon is objectively how it works when it comes to resolvability. Way too complicated. Don't address the argument. That's for sure. What you can't do is address it. So we're going to go back to enjoying this beautiful sunset. We're going to have it overlaid. We're going to let honest people examine it. Right? You guys complain about being censored, but then block and censor me. Shocking. You're sitting right here. Your name is Have to Lie to Flirt. But actually, I specifically say don't block them just because they disagree. Only if they're being toxic and spamming insults and stuff like that. I don't like to censor people. Although typically you guys are here every week. You're not being censored. Anyway, if you're insulting people, yes, you will be eventually. If you're spamming insults and distracted, you'll be timed out. All right. Anyway, let's go back. And this is for the truth seekers. For those that say the sun set's impossible on a flat Earth, it's mind-blowing to me. So we're going to bring it back a little bit, and we're going to keep watching. And the sun has just disappeared up above the horizon. This pole here is actually floating above the horizon, as is this one. So we see it do exactly the same thing as this image. Exactly the same. Look at it. As it's going further and further, it's melting. It looks like it's melting into the horizon. Well, that's what happens due to perspective. Again, this is an experiment done by Harvard University, changing the aperture, thus changing the resolvability, the angular resolution, which many people often conflate with angular size change. Those are not the same thing. Okay, and this is based on propagation and reception angles. What you will never hear is direct specific rebuttal, by the way. And that goes to show you all you need to know. So there you go. What a coincidence. The sun does the exact same thing. And then look what we see. Now, the Earth is supposedly curving, causing this horizon right here. But we see this is up above the horizon. This can be blocked by the curve. Wait, or is the curve of the Earth up here, but invisible? Well, this is the curve of the Earth. Oh, but this isn't the actual curve of the Earth because we never see the actual curve of the Earth. We know it's there, but we can't prove it's there. We can never see it. We can never find it. But trust me, I promise, if you beg the question that it's there, it's there. But look, this pole is floating above it. So then we're just going to keep watching. This shows you that the sun disappears from the bottom up due to angular resolution within the atmos, which is, of course, most dense at the bottom. So let's just keep going. Watch it one more time because I think it's one of the most beautiful videos ever. So beautiful. Shout out to my boy Rakia Life. I dropped the link in the chat, and he's got 500 subs, and I think we did have a lot to do with that. But if you guys can go sub to him to motivate him to keep taking videos out on the ocean, that would be very cool. That's my homie. All right, now what we're gonna do is address the other nonsense straw man. So thanks, Walter. What is going on? Okay, now as for it's not getting smaller, because I just would like to point out that's what one of the ballers in the chat are saying. It's not getting smaller. Don't address the fact that it's disappearing from the bottom up, identical to the experiments that can be replicated and have been in very precise lab settings thousands of times. Don't address the fact that angular resolution limit due to the diffraction line of the eye level will actually cause objects to disappear from the bottom up due to the propagation and reception angles falling below the resolvability of the angular resolution limit for the human eye, 0.02 degrees. Don't address that the sun is observed doing exactly what we see with those tests, changing the aperture, thus the resolvability, proving things will disappear from the bottom up and look like they're merging into the diffraction line or at the horizon. Don't address that. By all means, don't address those things. Don't address that the sun does exactly what we see when we look at street lights going down the street, looking like they're going down, and we show the time lapse of both of them side by side. Don't address that. Ignore all of that and say it's not getting smaller, saying that it should be changing angular size. If you straw man the flat Earth, right, then you're getting close, buddy. Right? Strawman flat Earth, it should change angular size so much and come up with all these stupid values and all that stuff, right? Now, what these same people will do when they're shown these direct refutations of their talking points, which is the sun can't disappear from the bottom up if the Earth is flat, proven wrong. That the sun wouldn't move in the sky the way we see it if the Earth is flat, provably wrong. That the sun only disappears behind a physical curve of the Earth, provably wrong with the video showing that it clearly disappeared up above the horizon from the bottom up. Don't address that. Right? Ignore all of these things. You should see it forever. We just covered literally that's not true with experiments from an Ivy League school. Don't address it. Don't change it. Nobody changes the aperture on the sunset shots. And there you have it. That goes to show you just don't understand it. You don't understand it. If you would use Zoom, you could come on and please say that out loud, but anyway, and we're going to do a more in-depth presentation, like a PowerPoint, about things disappearing from the bottom up. All right. I'm just want to point out these tactics so you guys know what to go into. When people employ these type of tactics, there is no real point in engaging with them, certainly not getting like real worked up, even though sometimes I do need to work on it, admittedly, because they're just not here in good faith. They're not having the conversation in good faith. And this goes for your friends, your family, people on the internet, anyone, right? Like if people can't engage in good faith, then it's pointless conversation. The pointless conversation, right? So an example of bad faith would be to make all those claims we just covered, to be specifically refuted with them, to ignore all the refutations, and then jump over here and make a totally different point, right? And then the next time the conversation comes up, say all of those points that were refuted again like it never happened. Those people are useless. I've seen Jaron and Rob Skiba do experiments with magnifying lenses that show objects disappearing bottom up. Do you agree with those experiments? It's a little bit more nuanced than that because they talk about the way that the light is bending relative to the actual lenses and is it making it bend down, and then they're saying that it bends down the opposite way than it does in the Atmos, and that's a more complex aspect of it. Well, I just want to cover each point first. Okay?
If only Globers would listen, they would see the answers to their questions. And stop ignoring the proof they want so badly.
They don't want the actual evidence.
I've seen Jaron and Rob Skiba do experiments with magnifying lenses that show objects disappearing bottom up. Do you agree with those experiments?
It's a little bit more nuanced than that, but yes, it does show that magnification causes things to disappear from the bottom up, and in fact, they try to say that it's not equivalent because there's a circle. They say the same thing with like how they say that light bending down will always lift objects up, but then you can put a pencil in a glass of water and it goes down. They're like, oh, it's because it's curving. First of all, your eyes are curving, and we see the Atmos through a curved lens, no matter what optics we use, so debunked and refuted. Secondly, even in a pool where there's not a curved glass that like lens or lensing effect due to the curvature of the glass, you can still see it go down. It's actually based on the viewing angle and the angle of incident, along with many other variables as to exactly what the light's going to do relative to the change in medium, and this will always be ignored. So it's not that I disagree with them. I just think we need more precise, detailed demonstrations, because what I'm showing you is the answer. Because science says so. It doesn't really matter how much people say nuh-uh. It's called bokeh. You were lying. Look it up. Okay. You're a troll, bro. Oh my god, more word salad. I'm just gonna make flat earth disappear by logging off. Good night, and stop using our technology. Hypocrite can't straw man flat earth when there's no model. no better time than to, like, as you can see that those people are just like white noise. They can address the subjects in the stream, and it's every stream. Every single stream, they ignore the specific evidence and arguments being discussed, and they just gaslight. I would not want to be like in that group of people. You should just step back and reconsider. But yeah, we have all kinds of flat Earth technology, like all bridges, canals, railways, rail guns, like all of the aircraft used by the military are ever created and designed ever, like all ballistics, all trajectories, everything is designed on a plane, Earth, all of it. So, ironically, you stop using our technology, you only fly a plane that is actually flying, accounting for a spinning, curving, tilted, wobbling ball, where the mechanics are engineered relative to curvature. You only go use railroad tracks and railways and bridges that are accounting for curvature. But okay. So that was plenty of attention given to that nonsense. So now the next thing that they say is that it can't be true. Now we just demonstrated that not only can the sun set on a flat Earth, it's exactly what would happen on a flat Earth, and the globe ignores these aspects. The globe explanation doesn't even like incorporate these scientific facts. And yes, it's science because it's naturally occurring observable phenomena that can be manipulated with experimentation. It has an empirical means. It's observable, testable, repeatable, falsifiable. Okay? This is physics. So denying it is pretty weird. Pretty weird. Oh, but the better explanation is that the sun isn't really there. It just looks like it's there, but it's actually down below a curved Earth, but it looks like it's up above it, and we're falling backwards but can't feel it. The sun looks like it's moving away, but it's actually not moving at all. Okay. Now, so they say that the angular side, they say, the person said in response, because their cognitive distance shorting out, so they had to just, script. It's not getting smaller. Okay. Well, that's a globe Earth problem for starters, because the globe claims specifically due to geometry that it should be smaller, get bigger up to noon, and then get smaller again. Based on basic geometry. Again, you got a curved surface. You got over here, the sun rises. You're closer to it, and then as it's going up in the sky optically, now, or it's really going to be further away at sunrise, and then you're going to be closer at the top of the curve, and then you're going to be further away again. You have a curved surface, right? So the sun is going to be the closest at the top of the curve.
What about our super chat battle? You are almost catching up.
Thank you, Ron Boston. All right, so it needs to change angular size on a globe based on geometry. It has to change angular size at a very specific rate, right? And it has to go from bigger to smaller to bigger. It has to. Never been measured ever. So when you say it's not getting smaller, the fact that it's not changing angular size, it has to get smaller, bigger, smaller. That's a globe problem. Now, there was never a globe. We all got duped. Earth is at the center. Correct. Thank you for 777. Now, here is why it's actually only a globe problem. So, thanks, Walter, here. But I don't know why it doesn't have a little personal dome. How do I turn this on? I don't remember. All right. Now, as we go through the day, we're going to see, let me change the direction. All right, so this will be us seeing the sunset. All right, watch. Now, as it goes throughout the day, so the sun is actually up here, right? This is the actual position of the sun, but everyone has a limit to their view. You have 360-degree field of view. If you look all the way around, you have 360 degrees. So not technically a field of view at any one point, but you have a horizon around you, 360 degrees, and you have a limit to how far you can see. You can't resolve things forever. It's absolutely insane that people think they can. So as it gets close enough, it enters your azimuthal grid of vision, right? Azimuthal grid is simple, right? You have the observer position in the middle. You have your zenith position, which is directly above you. Then you have your azimuth, which is you looking out around the horizon to get a direction. So now you basically have an L that's perpendicular. And you take angle measurements between that. And this is, if you do this all around you, it's going to give you this right here, an azimuthal grid. Now this is how we see, because we are actually looking at the sky to get those measurements in the first place. Okay, now, as the sun gets close enough, it pops into this limited hemisphere of vision, and it starts to rise. And then it's going to keep going. Now you see the actual position is up there, but we're just seeing it within our limited field of view. And then it keeps going down, and then it sets. It doesn't change angular size, because if you look at this line inside of here, it's at the same point. It's at the same point within that dome the whole time. So it's not expected to change angular size, because it's only picked up and perceived within that hemisphere of vision. So it actually wouldn't change angular size. Now on a globe, it has to change angular size. Let's see if they'll show us a video. Okay, so this is what's actually happening, right? It's just terrible, but it's not a good depiction of yours. So I've explained it a couple times, but obviously if you have a globe, right, then the sun is going to be closer to you at the top of that curve. You have a curve. If you're at the top of it, you're going to be closer to the sun than when you go down further away. So the globe predicts that the sun will change angular size throughout the day, right? It'll be small, get bigger, and then back to getting smaller at a very specific rate based on geometry. Where's the measurement for that? It doesn't exist. People claim, oh, it's too small to measure. That's incorrect. Provably, we have optics that can measure it. Why has it never been measured and verified? If it doesn't change at that very specific rate, the globe is debunked irrefutably based on geometry. Never been observed. Just hilarious that the angular size change argument actually debunks and refutes the globe, yet makes perfect sense on a flat Earth because it's just entering your hemispheric limit of vision. So you're not expected to see it change angular size until you get throughout the year. Now, as you see here, now it's further away. So this is where you will change angular size throughout the year, because now the sun's actual position, if you mount some, is further away throughout the year. There you go. Now they just looked at the sun, right, and then they claim that actually the Earth is moving on that path. Okay, and I just to point this out again here. You look here. This is the diffraction limit of why the sun sets. Okay. And then you come over here, and this is exactly what we see in reality. There's really no way around it. Here, I'm going to place for a second while I just look up another video. But just in case the cognitus was too much, we're going to play it briefly again. But I'm going to find this other video for us real fast. Okay, now, it's just, what a coincidence, it's just the same exact thing. All right, circle represents the sun on the left, of course, and then it's merging into the horizon. which is the diffraction limit. It is your angular resolution limit, your vanishing point. You can't see forever. It's asinine to claim such a thing. Okay, now we're going to come over here and we're going to, again, we showed that this is identical to this. So this is the sunset time lapse here, as you see. See what the sun does in the sky throughout the day. And here is street lights going further away from you, though they're all at the same height. Probably not a coincidence. All right, now we're going to show this, and I want you to think about this, okay? So it gets to the point where you can no longer make things out because it reaches its diffraction limit. And as I explained, the bottom will be reached first, okay? The bottom will be reached first, right? So things will disappear from the bottom up. So keep that in mind. It reaches this vanishing point. Say this is the vanishing point, okay? Now the thing is moving towards it. Now you can't see it. It starts to disappear. It can no longer be resolved. And this is like the horizon, the vanishing point, right? And so it's based on optics. It's based on aperture. It's based on propagation and reception angles relative to the diffraction line or the eye level, right? But also atmospheric conditions. The atmos conditions also fluctuate and they exaggerate these effects, right? It's like putting on glasses, right? So this exaggerates the effect here, right? Now these aren't actually, I don't have any prescription glasses, but you get it. That's what the atmos does. And so when there's different conditions, you have a different exaggeration of this effect. Now, watch this verification that this is why things disappear in the distance, which we just watched the sun disappear above the horizon from the bottom up. So it isn't the Earth curvature blocking it. Okay, now let's watch this right here.
Water. The optical illusion was spotted off the coast in southern England. According to meteorologists, the illusion is called a superior mirage. It happens because of special atmospheric conditions that bend the light. Cold air sits right above the seawater with warmer air above it. The visual phenomenon is common in colder places like the Arctic, but has occasionally been seen in the UK during the winter.
Okay, now this is very important to understand. So obviously the water is up here, or what's going on? Now we know that things ramp up, okay? So this is certainly due to atmospheric conditions, right? But let's explain what's going on. Well, this bottom portion here is reaching the diffraction limit, right? So it's going to start to lose resolvability, so you can no longer make it out. You can no longer see it. So it's losing resolvability from the bottom up, which is why the boat looks like it's floating on nothing. The atmos exaggerates this effect. Shout out to Travis, who call it the ether band. This exaggerates the effect, which is why it looks like it's floating on nothing. Okay, so if we come back over here, we watch this pole back here looks like it's floating on nothing, right? And they will have you believe that this is the curve of the Earth, but no, it's not. So they say you can't have a hard line without a ball. Well, this isn't the curve of the Earth then, so why can't we have a hard line? So if you see here, obviously this is just reaching the diffraction line. And so it begins to disappear. It disappears into the horizon, into the vanishing point, right? Relative to the diffraction line, not behind a physical geometric horizon that can never be seen, never be found, never been isolated. I promise it's there, but we never see it, and we only ever see the apparent horizon. No, it disappears into the vanishing point. Look at that. The sun is disappearing up above the horizon. The globe model says that this sun is already down below the Earth. You just can't tell. Okay. So this is a very basic, this is like true Earth 101 stream, but I'm just tired of hearing this whole idea that sunset's debunk of flat Earth. It's so stupid.
Glad
So we
I got
addressed
out
it.
of work early and can watch the stream live. Mad love, brother. God bless.
Thank you, man. Thank you for being a miswit. All right, over here. See it. All right, here. Let's check this out and let my boy talk to you. Well, we addressed it disappearing from the bottom up. Now, what they've now said, which we just covered this. We just covered this in the horizon. So watch that if you're confused about the horizon. We explain it's very simple. The horizon is just an apparent location where the sky appears to meet the ground. That's the definition of horizon. And of course, horizontal comes from that word, horizon. And to say that there'd be no horizon on a flat Earth is super goofy. This is where the sky appears to meet the ground. So are you claiming that there would be all sky or all ground? Now, what we commonly see when we look out, certainly in like a plane or with any height or over land, is it gets really fuzzy and it converges. It's like fuzzy convergence. It's blurry, similar to, of course, it's right here. Right? That's what we see. So to say that there would be no horizon is insane. Okay, and the horizon is the optical limit, and again, everything's disappearing based on the propagation and reception angles. All right, so let's check this video out. Let's see what my boy Dave's got to say about it.
Neutral.
Yeah, I'm neutral. I don't really care because it's not going to change my life. But anyway, David said he has a reason why.
That's the one thing that triggers me. When someone says what difference does it make, it's not going to change my life. It's going to change your life.
To hear what you have to say on
It's
that.
going to change your life.
Yeah, okay, cool. That's awesome. So I like to learn new things. Okay, so I observe the hell out of nature. Okay, especially being here in the sun in Mexico.
Nature doesn't
and
lie.
when you're at high noon here on the beach, and I put my hands up, and I know there's obviously light refraction that plays a role into all this, but when you're putting your hands up above to block out the light to look at the sun, to me anyway, from my perspective, I see the sun as a specific size, and then on the top deck of my casita, I have a fourth spot where I can go up there and I can watch the sunset. And to me, the sun is bigger as it comes down what it appears to be going below the horizon than above. Now, if it is going straight across the Earth, then to me it would be the same size, and it would get smaller as it moves away from us, and that just is not what has happened since I've been observing it here.
And that's because you do not understand what you're seeing. And tonight, I'm going to teach you all what you're seeing.
Cool.
Okay,
Awesome.
So I'm going to show you guys two tables. Are these the same width and dimension?
Well, I know.
You know.
Yeah, no, I've watched your stuff.
Okay, so again, so your eyes, it's very difficult. So this is just showing you that unless you can touch it and measure it, you can't really tell. So first, let's you guys, you probably have seen this, but I want to show it again because then I'm going to lead into something new that I'm going to show. Have you seen my flat Earth kitchen? Seen this?
Yes, I've watched your video on this.
Just real quick so people can see it. We're looking.
This is for our guests for sure.
We're looking at the sun from the elevation of the sun. This line is level. Yes, it's level. I verified it in the full video, but you can see that it's level. Here's my counter. Here it is moving along. This is it can be a cloud deck or a mountaintop, whatever. It's opaque and it's above it. Now we're going to look at the view of the same path from the table, from the far end of the table, and look at the line. It looks like it's going down. If I showed you this first and said, is this line level? You would say no, it's going down. And look, it never went below this, but this is from the viewer's point of view at your eye level. This is compressed into the horizon. Look at the line now. It's almost going straight down. Okay. So this is just without any atmosphere, refraction, magnification, nothing. Okay. Now we compare it to a real sunset. And look, it goes behind, this is the real sunset, an atmospheric deck. So this is that cardboard bottle thing I had, right? Yep. But your eyes can't see the difference between that line and the apparent horizon. And it all crunches together and it all just disappears beyond this cloud deck, atmospheric deck of opacity. So now we're going to talk about perspective. So when you watch some,
okay, now let's think about this for a second. Now they say there can be no hard cutoff on a flat Earth, right? And that the sun would just disappear all at the same time. Now that's a basic lack of understanding, right, of the resolution limit and perspective. And this is experimentally valid. Let me come back over here. Weak ghost story or whatever gaslighting tactics. People, you're insane. You don't understand all this stuff, right? Just gaslighting. All that's relevant. This is experimentally validated. It's been done in university lab experiments thousands of times. So denial of this is denial of reality. Now let's look very closely here. Now you see the sun setting in Dave's image here that he's pointing at. You see a hard cutoff of the sun. A straight horizontal cutoff of the sun. Now we see that the horizon looks like it's down here. So the globers have been saying, since we took away the geometric horizon, they used to claim that that water line right there is the curve of the earth. Then we showed it fluctuates constantly like we did in last episode. So now they say, oh, well, you never see the actual curve of the earth. You never see the actual geometric horizon, but I promise it's there. Well, you only ever see the apparent horizon, but you couldn't have an apparent horizon without a geometric horizon. That's their new talking point as they've moved the goalposts over the last like 7 or so years, as we've just destroyed the globe day in and day out, right? So now they say you can't have this hard cutoff horizon, that it would just be blurry. Now we showed in last week's episode that if you go up, you see it is blurry, right? Now under the water, you get more of a defined line, but if you zoom in, it's still blurry, just like the image right here. Just like this image, which is again from Harvard, doing an experiment. Okay, now, what this shows you is that even though it's up above the water and what we see is the horizon, you definitely can see a hard cutoff, a distinct line that the sun disappears behind up in the air. Up in the air where you see nothing but sky, all of a sudden the sun's doing this. It's because you have, of course, turbulence, you have a more dense atmosphere at the bottom, and you see it disappearing. And before we continue on real fast, I want to point this out. Okay, and we'll cover this more in depth on why things disappear from the bottom up. But light attenuates, okay? And that's just a fancy way of saying it's absorbed. So when say light, now I don't think light travels, right? It's just perceived, the illumination is perceived propagation. But just for intensive purposes, we're going to say travel, right? As the light goes through a medium, it's absorbed by that medium. It's absorbed relative to the medium. So the attenuation rate is relative to the density of the medium and the turbulence of the medium. So it's absorbed. Now, at the bottom of the atmosphere, you have the most turbulence and you have the more dense part of that medium. The bottom of the atmosphere is the most dense. So the light is attenuated at a greater rate at the bottom of the atmosphere, which will also make that light no longer be visible sooner. So thus, as something's moving away in the distance and you're looking at the light of whatever it is that's moving in the distance, the sun, which is a light, of course, as you see the light that is the sun moving in the distance, that light is going to attenuate faster at the bottom of the atmosphere because it's the most dense and most turbulent. It's called attenuation. Also, just undeniable and verifiable science and physics that can just be experimentally validated 1,000 different ways. So we're going to actually see it now as the light gets completely absorbed and it completely attenuates, you can no longer see it. So it's going to reach that point where you can no longer see it because of attenuation first at the bottom of the atmosphere because it has a greater attenuation rate. Okay, now we're going to cover all this in depth with the PowerPoint on why things disappear from the bottom up, but it's important to understand that. You combine that with the diffraction line with the propagation angles and the reception angles relative to that diffraction line or eye level, right? And simply as the propagation angles and the reception angles get below the resolution angle, right, you can no longer see it. It is no longer resolvable. This is why things disappear from the bottom up. Now, I just wanted to point out that here, when you're looking here, there's a hard cutoff up in the air. This talking point is just so desperate. And they will just, once we really nail this down, by the way, they will just shift the goalpost again. But it's okay because who cares what they do? This truth is not for everyone. And we have to kind of just accept and understand that. All right, let's continue on.
Cloud deck, atmospheric deck of opacity. So now we're going to talk about perspective. So when you watch something go away, it gets smaller. Bam, it just goes away and it gets smaller because you are at the same level as that thing. As it goes away, it gets smaller. Nobody disagrees with that. So this is perspective, and it literally goes away until it disappears. Now, these lines are all level, but look at these lines here. These are almost going straight down, okay? This is a hallway, and it's level, but your eye perceives these as going down. So here we have a sun that's already elevated, okay? it's really going straight across, but due to perspective, it goes down. And this is what an observer would see. This is like a cross view of it. And this is what you would see. Though this sun is just going down due to perspective, like I just demonstrated. Okay? So I forget what the name of the effect is. So here are the train cars. It's already reduced.
Yeah.
And as it goes away, it really doesn't change size very much. So this is a cartoon. Let's look at it in reality. Here's two balls, okay, that are the same size, 6 feet apart. The one in the distance is way, way, way small, okay? So we have a camera looking at it. One's very close, one's very far. It shrank already, as things do as they go into the distance. But when we lift the camera up, straight up, not getting any closer to the other one, watch what happens, okay? Because when something is already away from you, its perspective drop gets less and less. And at 7 feet high, they're pretty much the same size, right? So if I move this ball along the track, it's not going to get any smaller. And perspective tells you it's going down.
And it's even more so the case when you understand that it is around the same size because it's so far away. Inside your hemispheric limit of vision, also proven with experimentation and repetitive observation, denial of any of the things invoked in this stream is denial of reality. So you got to let go of the sunset. If you think the Earth's a ball, you got to stop saying sunsets debunk flat Earth. It's very, very rudimentary and remedial. So this is a perfect explanation of how once it reaches within that limit of perspective, like right here, this is the sunset right here. And as you can tell, it's not going to change angular size. Okay, continue on.
Okay, this is all just a trick of the eyes.
Yeah,
and that's how it works. Now, here's another thing. There's two more things I'm going to tell you. One, as that sun is going away, as it becomes lower and lower, you're looking, like when you're looking at the sun above you, you're looking through just a little bit of atmosphere. But when you're looking at the sun away from you and it's already dropped, you're looking at it through all of the atmosphere. And when you're looking out over water, there's moisture in that air. So as the sun is going away, remember, it's already up. It's not going to get much smaller. It's also being magnified a little bit.
Let me just address this here. Slinging ridiculous insults doesn't do anything. I'm here with no negativity, 30-some years of globe, and I want to ask questions, research. You problem if you can't handle that. I don't know exactly who you're talking to, but I would like to clarify this here. That is what this show is for. It's literally for open-minded people that think there's a globe and want to learn about this, the fact that we discovered it's not. It's actually a topographical stationary plane. Okay? When people are just spamming insults here and they're here every single week and they never listen, then I call them out. I didn't spam any insults to anyone. I didn't sling ridiculous insults. Okay. Moving on.
Sometimes, not every day. That's why sunsets look at different sizes on different days. Okay? It's called atmospheric magnification. That just plays a little part. And then the last thing is, it's really not bigger. When you see, the next time you guys have an opportunity to see a moonrise or moonset that is gigantic on the horizon, well, you go, wow, that's big. It's not. It's the same size as this one above you. And the way to do it, you know, you think, like, wow, look at that moon. You take a picture, and you look at the picture and go, well, it's tiny, right?
Yeah.
But you look at it, it's gigantic.
Huge,
it's your mind. Here's what you do. Sounds gay. It's not. Turn around, spread your legs, bend over, and look at the moon upside down through your legs. And it will be tiny.
You're kidding me.
It will be tiny.
Why?
Because your brain short circuits and it can't.
Oh my God.
It's totally a short circuit. It's the way we see things. We don't see. Yeah. So the whole argument of the sun not getting smaller, and by the way, it does get smaller many times, depending on the.
Try it out later.
Yeah. Is it a full moon?
No, it was a few days ago.
Yeah. So, well, it might be big enough. But this was taken by a soldier in Afghanistan, super dry, not over the water, and no humidity, and the sun just goes away. Paul McCartney knows the fool on the hill sees the sun going down, but the eyes in his head see the world spinning round. And this, look, we are spinning backwards at 1,000 miles an hour.
Yeah.
Why isn't that sun going down? It's just going away, and it's getting smaller and smaller and smaller until you can't see it anymore. Okay, so.
And then you zoom in, and then you'll see it again.
Well, here's one. Looks like this one's setting over the water, right? But as I showed you before in my kitchen one, you can't see that there's space between the sun and the water. And when you zoom in, because these clouds over here are the same height as the ones above you, but when you zoom in, oh look, it's not touching the water. It's still up there. Oh. And then over distance, like right here, becomes opaque, and the sun will just go behind that. And it looks like it's going down. It's not. We showed you that with the perspective. And it looks like it's disappearing behind the horizon, but it's not. There is no physical horizon. We can see too far. It's all nonsense. Next.
I love this guy.
That was a good explanation.
Shout out to Dave. He obviously crushed right there, per usual. All right. So.
We have two independent laser beams set up such that we get parallel beams. And these beams are about 7.5 millimeters apart.
Then the two beams travel down a long hallway, bounce off a mirror, and then come all the way back for a total distance of about 84 meters.
If you look even in this small local area down this hallway, the lights look like they're going down.
Then come all the way back for a total distance of about 84 meters. By the time the beams have traveled that far, they've both grown into large blobs that overlap, and we really can't tell that we originally had two laser sources.
So next we bring these beams through a lens so that we can image them on a CCD camera. We use these filters to attenuate the light so that the intensity is low enough that we get good exposure.
We can control the diameter of the lens using this aperture we've placed in front. If the diameter of the aperture is wide enough, then we see the image of both laser sources on the CCD camera.
As the aperture closes, the resolution degrades.
Keep in mind that you want to flip this around like our image here, because we see it like this. So just flip this perpendicular in your mind as you watch this demonstration. This is what we see, right? So just keep that in mind.
So that the intensity is low enough that we get good exposure.
We can control the diameter of the lens using this aperture we've placed in front. If the diameter of the aperture is wide enough, then we see the image of both laser sources on the CCD camera.
As the aperture closes, the resolution degrades and we see only one spot. The Rayleigh criterion occurs when the aperture is open just wide enough that we can distinguish the two spots.
For our setup, this aperture diameter is about 8 millimeters. Diameter of the lens.
So of course you see here, this is Brigham Young University. And I'm just going to watch the video one more time. I want you guys to kind of pay attention. This is about Rayleigh criterion. Look at the diffraction line. Watch what happens. Imagine it flipped over. This is, again, the same exact thing we see with the sun. It is not a coincidence unless you're in blatant denial. Yes, things would disappear from the bottom up optically over a plane surface. This is a fact. Let's watch it one more time.
We have two independent laser beams set up such that we get parallel beams. And these beams are about 7.5 millimeters apart.
Then the two beams travel down a long hallway, bounce off a mirror, and then come all the way back for a total distance of about 84 meters. By the time the beams have traveled that far, they've both grown into large blobs that overlap, and we really can't tell that we originally had two laser sources.
So next we bring these beams through a lens so that we can image them on a CCD camera. We use these filters to attenuate the light so that the intensity is low enough that we get good exposure.
We can control the diameter of the lens using this aperture we've placed in front. If the diameter of the aperture is wide enough, then we see the image of both laser sources on the CCD camera.
As the aperture closes, the resolution degrades and we see only one spot. The Rayleigh criterion occurs when the aperture is open just wide enough that we can distinguish the two spots.
For our setup, this aperture diameter is about 8 millimeters.
Camera.
So there you go.
This aperture we've placed camera on the CCD.
Important to pay attention and just think about that flipped upside down. One of them is the sky. Or flip perpendicular.
The resolution degrades and we see only...
Boom, that's what the sun does as it moves away. One more.
Angular resolution is the ability of any image-forming device, e.g. camera, eye, telescope, to distinguish small details on a celestial object, such as craters on the moon, or to clearly distinguish between nearby objects in the sky. So let's look at this latter example. We want to look at different objects that are nearby in the sky. So for example, here's our eye, and we're going to do some naked eye observing of two orange stars that appear nearby in the sky. One star could be really far away and the other one could be close, and we don't know their distances. They just appear to be close in the sky. Now, if we have a small diameter telescope, then we might see the two objects as one, and we would not have a very high angular resolution because we cannot see the two objects separately. If we bought a telescope that had a wider aperture, we might be able to start to see two distinct objects, but it's still not clearly resolved. So of the three images, the top image clearly resolves the two distinct objects, and that telescope would have the largest diameter, the largest aperture, to have the highest angular resolution of the three telescopes.
Very basic stuff. Very basic stuff. So again, look at the pictures. Look at the picture. Someone's saying, let me just read, like the best rebuttal.
Yes, people fake dino bones, but dinosaurs existed with man. They are in Book of Job, cave paintings, also dragons are depicted in cultures who never could have met. Young Earth and Flat Earth need to join.
Young Earth and True Earth seem to already kind of be joined, to be honest, but yeah, I don't think that dinos existed as they said, but I think there were bigger creatures. Yes. Thank you for the super chat. What do you say here? No kidding, it's established science, but the similarity is meaningless. Oh, that's a nice substantive refutation you provided there. Just nuh-uh. And no expert appeal to authority and consensus. So you got nuh-uh, appeal to authority and consensus, would agree regarding any of your conclusions. So just a giant nuh-uh peppered with other, fallacies. Hand wave dismissal. What a joke. And that's the only time he's been spamming comments this whole time. First time he even pretended to actually rebut it. Then he rebuts with, this is literally like some other guy, Derp from 2016, just an ad hom. Just an ad hom. So that's the best, just in case you were wondering if you're watching this as an honest viewer trying to figure out what's going on. That's the best that these veteran globe proponents that are always in class but never pay attention have come up with in the entire stream. So I want everyone to pay attention to that right there. And of course, again, this right here. Let's get to where... See that right there, and then you watch it, of course, merge together. And then I want you to, again, for the third time, just so everyone fully grasps it, I want you to think about and understand that the aperture is changing, thus the resolution is changing. So it makes, even though there's two distinct light sources and lasers, it makes the circular light sources look like they're merging together. Of course, we have one, that's the sun. And you have the optical limit. This would be like, this line right here would be the horizon because it needs to be flipped up. And I'll make a dope short edited video. I'm going to start trying to make edited videos that summarize these concepts in 2, 3, maybe 5 minutes when I get some time. Okay, so we've seen that. Now I want to just see this one more time. We're going to watch it from beginning to end so that everyone can understand it. What is going on? Which one of these songs was good? I don't remember. Wait, where's it going? I thought it had to go behind the curve of the Earth. Okay, I mean, we showed it so many times, there's no way to deny it at this point. So now we'll get a bunch of red herrings. And we just got another one. The position of the sun's rise and sunset, debunk flat Earth. Okay. And here we go. Thank you, Walter. So this is patently false. Here is the position of the sun. This is throughout every day of the year. This is with every latitude and longitude throughout the day. And as you can see here, we see that the sunrise and sunset position absolutely does not, in any way, even on the equinox, debunk flat Earth. You have a hemispheric limit of vision, and as the sun moves, it looks like it drops in that limit because that's reaching your limit of perspective. So it's dropping down. It's going to maintain angular size, and this explains the position of every single sunrise and sunset throughout the entire year, every day of the year. And this brings us back to, of course, that's what happens. Not sure where it is. There we go. There's the streetlights. And here's the sunset time lapse. What a coincidence. Isn't that interesting? It's almost like they're the same. There we go. Wow, look at that. It looks the same as the time lapse of the sunset. So, there you go. It's just a fact that not only does the sunset work on a flat Earth, it's exactly what would happen on a plane Earth. So, this is just a fact. The funnier part is what they, so again, let's recap the stream. They try to say that sunsets debunk flat Earth because A, the position of the sunrise and sunset doesn't work on the flat Earth, and they typically talk about the equinox. Debunk, thanks Walter, hemispheric vision, azimuthal grid of observability or of vision, some people call it a personal dome, provably how we see. We see crepuscular and anti-crepuscular rays curve over top of us. This is why we see rainbows the way that we see them. We know for a fact we see this. There have been many experiments with machine learning, specific robotic experimentation, all kinds of different experimentations, alley experiments, all kinds of things show us that we do not have perfect Euclidean geometry vision. And of course, we know that we see in a dome, admittedly, according to Vanderbilt University, that there is a celestial sphere, even according to mainstream astronomy, right? Because we take our azimuth, or our zenith directly above us, then we take our azimuth, and I covered this in a Skull and Globers that's specifically about optics. It's about how we see the sky. I think it's called Eyes to See. So you have your azimuth out to your horizon to get your direction. Then you have your zenith directly above you that gives you a perpendicular L, right? And then you take your elevation angles up from your horizontal baseline, right? And you do this all around you and it gives you a dome. This azimuth is used for sun calc. This is used for stellarium. This is used for the current globe model, even, to map out the sky. Because when we go out and we look at the sky and we take angle measurements, this is what we get. It's just absurd to deny it. It's what we get when we make observations. We have crepuscular and anti-crepuscular rays that curve and connect in each horizon. Even when the sun's setting in the west, we see anti-crepuscular rays in the east. And they curve up above you and come back down. So this is just a known fact. So when we apply this to what we see in the sky on a plane, it explains all celestial observations, including the sunrise and sunset positions of everywhere on the earth at any day of the year, everywhere. Okay. So that one's debunked. The idea that the position of the sunrise and sunset doesn't work on a flat earth, you can keep saying nuh-uh, but this can be demonstrated. Just take a plane surface, put a little dome over there to represent like the basically the magnification optics of the hemispheric limit of vision that we have in reality, provably with experimentation again. And you take a light source, move it over top of that flat surface, you're going to see it doesn't change angular size, and it's displaced from its actual position based on being inside that dome. And it's going to do the exact arc we see in reality. What a coincidence that, once again, the demonstration perfectly matches reality, right? Okay, so that one's wrong. The position of the sunrise and sunset, even on the equinox, debunking the flat earth, that is incorrect. Okay, so what's the next thing they say? They say, well, the sun would never disappear from the bottom up. We just covered that that's objectively not true. The more dense part of the atmos has the higher attenuation rate, which is a fancy way of saying absorption rate, how the rate at which it's absorbed into the medium. And of course, it being higher at the bottom because the medium is more turbulent and more dense at the bottom of the atmos. That means the light's absorbed or attenuated at a faster rate there. Therefore, you will not be able to see it from as far away because the attenuation rate is higher. So when the light's completely absorbed, you can't see it. So that's what we see with the sun also, or with distant objects. The bottom of the object, the light that we use to resolve that object, is attenuated faster at the bottom because it's more turbulent and more dense. This is explained that since there's a gradient of pressure and turbulence and density, that there's actually a gradient of the object disappearing, right? So that's one obvious, objective, scientific, and physical fact that explains a variable of things disappearing from the bottom up over a plane surface, as well as Rayleigh criteria and simple resolvability. Angular resolution limit of the eye, for example, is 0.02 degrees. So whenever the reception and propagation angles of whatever you're viewing falls below that resolution angle, you can no longer perceive it or see it. You can no longer make it out. It's no longer there. You can't see it anymore. It can't be resolved. It can't be seen. It does, in fact, disappear, right? And this is, of course, you have your eye level, your diffraction line, right? And then you have the objects being closer to that diffraction line from your angle, and it's going to reach this diffraction line, disappear sooner from the bottom up. So these two things combined are going to assuredly make things disappear from the bottom up. And then we have an exaggeration of these effects based on the atmos conditions of that particular day and particular time of the observation. Okay? The next thing that they say, so those are directly refuted. We just showed direct experimentation from Harvard. I have them from Stanford. You have them from Cambridge. You have them from BYU. Physical demonstrations and experiments showing that this diffraction line will cause the sun to do exactly what we see it do in reality, right? Appear to converge into the convergence point that is the horizon. Now they will then also say that the sun would be above the earth forever and it would never be nighttime. We just debunked that with the attenuation explanation as well, which is just basic physics. So any explanation of the earth and where we live and how the sun works has to incorporate all of these things that I'm stating because they're just physical, verifiable facts. So denying it is quite a crazy thing. So then, once all that, so the sun can in fact disappear from the bottom up. Sunsets are for sure not only possible, but exactly what would have to happen on a plane earth, because of attenuation rate and resolvability, right? So we do see the sun go down in our view, not because we're spinning, falling backwards on a globe and the sun sitting still just looks like that, because we can prove that due to perspective that things will look like they're dropping down in the distance, just like street lights that are all the same height, but as you look down the street, they look like they're going down, just like the time lapse of the sun, which are identical. And again, it's just a physical, objective fact. Cannot be denied and would have to be integrated into any explanation. It's interesting that all of these are ignored for the globe explanation, though, side note, but we're showing that the evidence shows it is in fact on a flat earth. Now, what we also see is it's not just a physical geometric horizon blocking anything. Now, the globe proponents have moved the goalpost and said we never see the curve of the earth or the geometric horizon. Now we only see the apparent horizon, but I promise there's a geometric horizon there. Well, we see that even that horizon line, which is somewhat fuzzy and it gets more distinct at certain times or maybe over water typically, right? We see that the sun can disappear above that, right? Just like the video we showed, just like the video that Dave was showing, because there's opacity and you have like basically the ether band, as Travis would call it. You have a layer of turbulent atmos that's going to obscure things in the distance. You're not going to be able to receive that information because of the obscurity resulting from the turbulence and density of the atmos, right? So we see that the sun actually disappears above the horizon consistently. We see that quite a bit. Now the horizon is the vanishing point, so normally they're going to start to disappear at the same point, just like we saw when they changed the aperture, and you begin to see that it actually blurs into that point. Someone said, you don't change the aperture when you're viewing the sun. That just shows you don't understand that any aperture is going to have a limit, right? So the reason they're changing the aperture is because they're keeping the optics in the same position. That was the worst claimed rebuttal of this whole stream, probably. So then they revert all the way back to saying that the sun would have to change angular size. Now this is what's so important, as I've just now refuted each one of those claims with verifiable scientific evidence. If you then bring them back up again later and pretend that you don't know the refutation, you never rebut it, you never try to understand it, and then you just wait a little bit and then say it again, that the sun couldn't disappear from the bottom up or whatever, you're just being dishonest with yourself even, right? And I would encourage you to step back and think about what's causing you to behave that way. David, thank you for the $20 super chat. And in addition to this, they will claim that the sun would just disappear all at the same time. If it was on a flat earth, they would all just fade away at the same time. This is also objectively not true, because the bottom of that sun has a different reception and propagation angle than the top of it relative to the observer, or the eye level, right? So that everything doesn't disappear at the same time. This goes for buildings, mountains, the sun, right? The angle is smaller towards the bottom of what you're observing, so therefore it disappears sooner because it falls below the resolution angle faster or earlier. Okay, because there are millions of little points of light being received all over the object that you're viewing. It's not just one singular piece of light angle. It's all these different angles, and that's why it disappears from the bottom up, right? So all of those explain exactly why it disappears from the bottom up. The claim that it would all disappear at once is just objectively and patently wrong. So then they revert all the way back to the sun would have to change angular size. The fact the sun doesn't drastically change angular size throughout the day debunks flat Earth. And they say they'll even pretend they know how much it should, because they'll put a small local light source over the flat Earth and they'll straw man it using it basic Euclidean geometry in actual position. Now the sun we see is actually in an apparent position, provably so. And even according to the globe, it's in an apparent position because they claim it's down below the Earth, but it's actually lifted up and refracted so when we see the sunset, we think we're seeing the sunset, but actually it's already gone and below the curve of the Earth, being blocked by the Earth's curvature, but you just think you can still see the sun setting. It's not actually there, and they claim on the globe model in 2023 that happens every single day. You never see the actual sunset, according to the globe model. Of course, we just see the apparent position. We see the arc, which of course can also be replicated. I just showed you it modeled out. You can show it with a little demonstration. We have a hemispheric limit of vision, right? And this explains why it doesn't change angular size, because you're only perceiving the light within your limit. Now, I did a whole stream covering this. Say you have a little dome around you, which we provably do, and the celestial sphere is even integrated into any explanation of the sky. That's how we make the measurements of angles to the stuff in the sky in the first place. That's what we get. We get an azimuthal grid, a little hemisphere, right? That's what the planisphere is, a plane through a sphere. Right now, the globe hijacks. That's the only way to do any of it. Have a horizontal baseline, make the elevation angles, get the hemisphere, and they claim, oh, but it's actually the Earth's a sphere too, I promise, and we can see infinitely forever in directly straight lines. Okay, whatever. So we have this hemisphere. You pick the light up once it reaches within your hemispheric limit of vision, and that's when you can see it. So even though it could be far beyond that, you don't see it till it's within that limit. That doesn't mean you can't see it because it's beyond it, because there's light. Eventually you pick the light up inside your limit, and so it's not going to change angular size because it's always beyond your limit. So you're always picking it up at the limit of view, how far you can see. You're always picking it up at that limit, so it's going to stay the same. Now, ironically, the globe claims based on basic geometry that the sun must change angular size throughout the day. It must, of course, be further away, right? Thus smaller, And then throughout the day, as you get to noon, it should be closer, and then it should go back to being further away again. Because if you have a curved surface, if you're down here and you see the sun, right, it's going to be further away from you than if you come up geometrically on a sphere. You're going to be closer. You're going to be further away again. So you have the sun up here, and you're moving on this curved surface. Now, they'll say it's a very small amount, and it ends up being about 0.08 degrees, I believe. It may be 0.008. And the amount that it changes, people will claim, which no one ever talks about that, by the way, but the globe model predicts that the sun changes angular size every single day, and it goes up and then back down, right? So it's a very specific geometric physical claim that has to happen. The sun has to change angular size based on the geometry of a sphere. Very simple stuff, right? Has to. It's a very specific rate, and it has to change, and it has to get bigger and then smaller again. So small, big, small. That's how it has to change at a very specific, evenly distributed, symmetrical rate based on the geometry of a sphere. Never been measured ever. So ironically, angular size has to happen on the globe model based on basic physical geometry, right? Based on the geometry of a claimed physical sphere of Earth. And it's never been observed, never been measured. No one has any evidence for it. They claim you can't, now, like when I say they, I'm talking about people that just repeat scripts. They say you can't actually see it. You can't measure, you can't see angular change that small, but that's incorrect. We certainly do have optics that can measure angular size change that small, that can measure that minute of a change, but it's never been observed, never been measured. And if that doesn't happen, that debunks the entire globe model right there. So ironically, sunsets are a problem for the globe, because when we see the sun, it's not where it's supposed to be. They have to claim it's actually down below the Earth. It gets lifted up. They have no empirical physical evidence or measurement for this at all. They just claim that. And then we see the selenium, which someone was just talking about. And he's like, oh, the selenium is predicted by the globe. That isn't true. Because we see during the selenium eclipse, that's where the sun and the moon are both visible up above the Earth during the eclipse. But the globe model claims, of course, that the Earth is blocking the sun, casting a shadow onto the moon, which means the sun's supposed to be below the Earth, getting blocked by the Earth, thus casting a shadow onto the moon, the selenium lunar eclipse. Yet we see the eclipse happening, but the sun and the moon are still above the Earth. So how is the Earth blocking the sun when it's still above the Earth? And they claim, oh, refraction lifts it up. Well, they specifically claim that refraction always lifts the sun up to 0.5 degree, and we never see the sun. So what they're saying is, this is the globe model, is that every single time you see the sunset, actually the sun's not moving, it's just an illusion. You're falling backwards away from it, making the sun look like it's setting. But as you see that, it's actually a delay from what's happening in reality, because the sun's already down beneath the Earth. It just looks like it's still above it. And then, of course, we run into the problem also with the selenium, because it can be seen above that 0.5 degree. And you can't claim it's predicted or consistent astronomical refraction that accounts for every single sunset if you're then going to vary it based on however high you see the sun. And the predictions actually don't work, and they never actually incorporate specific refractive conditions. So that is not only multiple refutations of the globe, it is objectively explanation based on physics and science of how the sunset works. It's based on perspective and based on experiments that back up very specific optical effects and phenomena. So there you go. So the claim that it's not possible is just, you can keep saying it until you're blue in the face. It doesn't make it true. Here again is the time lapse of the sunset. Here are street lights going down the street looking like they're dropping down, even though they're actually all the same height. It's very basic stuff. Here is the model showing you that throughout the day, that the sun's not going to change angular size because it's all within that hemispheric limit of vision. And then here was our video showing that the sun matches exactly what we see with the experiment showing the diffraction line. If you look right here, the sun would be like when it's a circle above the horizon would be like here on the left. Then it begins to converge into the singular point and look like it's melting into that singular point. It's exactly what the sun does in reality. Then, of course, we saw that the sun in this specific scenario disappears up above the horizon, and we have all kinds of videos to show that. So debunking the claim that it has to disappear behind some physical curve, even though then they claim that isn't the physical curve. So there's a pretty specific recap. I don't think I'm talking smack or using filibuster. I don't think I just filibustered. I was very specific with specific points. So All right, I think we're good. Let me check Rockfin. A $20 tip on Rockfin. Logic and reasoning favors a stationary plane. True that. David Torrey, thank you for the $5 tip. Eric, thank you for the $20 tip, David. And Eric, thank you for the $5 tip on Rockfin. Shout out to Legends helping a brother out on Rockfin. Occasionally go watch us on Rockfin too if you don't mind. We are going to end up integrating Rockfin exclusive streams. So I'm going to kind of give you guys a couple of updates as to what's going on, but hopefully you guys enjoyed the stream. Not Austin. He's talking about chats again. Yeah, no worries. Everyone should be kind, respectful, and understanding if anyone's genuine and interested in this conversation. Anyone still claiming that the sunset debunks the flat earth? I just addressed every single thing that they could say. If you keep on saying the things after they've been directly refuted, but you refuse to actually rebut with substance specificity, you just say, you don't understand it, you're just making stuff up, you're just lying, you can't get it, no one would agree with you, all the experts would say this and that doesn't work, I promise, nuh-uh. And you say that the sun should be lit up, or the earth should be entirely lit up by the sun forever, there would be no nighttime, we would never see the sun set. It would stay at the same position in the sky above our heads. We would see it drastically change angular size. We would see it all disappear at the same time. If it couldn't disappear from the bottom up, that's impossible. If you continue to say those things, and they've all been specifically refuted in this episode, redundantly, I bid you farewell. You know, this is not for you. All right, so some quick updates. We are trying to finalize a house, so prayers for that is still, we're very grateful for anyone that's still praying for us to help us out with that, help us out with the decision and to get the right house, help us with a safe move, and all the finances is entailed. We trust y'all, so we know everything will end up working out. But thank you for all prayers in advance for that. So we should be doing that this month. It will be kind of hectic. I mean, we'll be really busy. We'll get the new setup. It's going to be very cool. You guys are going to like what I have coming for us towards the end of the year. Very busy next few months that we have coming up. I plan on jumping on a bunch of shows, having some guests. I may have a physicist on Friday or in the field. We may have a PhD physicist on this Friday and bring the show back. Hopefully that pans out. Either way, that show will be coming back. I know it was a big hit, so don't worry. We'll get it scheduled to where they're consistently booked. Hopefully no one backs out as they did previously, but we'll get that back rolling. We'll get the Wisdom Kicks It back going as well with different cool guests. If you guys have suggestions for the guests, message me on Telegram with your suggestions of who I should have on or what topic you want them to talk about, and we'll have them on Wisdom Kicks It. Some of these will be moving over to Rockfin exclusively, like the Wisdom Kicks It, where we can talk freely about whatever, and I don't have to censor the guest. So I encourage you to go follow on Rockfin. Wisdom Gets It on Rockfin. So you'll be able to watch them. Some of them will be premium. Almost all of them are free typically. And if they're not, they're available for free on the YouTube. So also, we're going to start a new series. I haven't decided if I'm going to replace one of the other shows or integrate it into one of these shows. Maybe even eventually its own channel, but we're going to start like a True Earth Court of sorts, where I'll be the judge. We'll either pick out 12 people that are just general population people, so they'll have a bias for the globe, or we'll let the chat you do it during polls. We'll have to figure out the best way to do it, where two sides present their arguments for basically the globe Earth or for a plane Earth. You have witnesses, cross-examinations. You have fallacy objections. I will rule without bias fairly on whether that fallacy was accurately invoked. It will either be sustained or overruled. You'll have your opening statements, which will say that the evidence will show this. You'll have all of your evidence that you present with your exhibits beforehand. Each side will be given their exhibits so they can know what the other person can bring up. You cannot bring up evidence that's not in that exhibit, and unless you're going to directly refute something that was brought up, but that's the only way. And then you have your closing arguments, and we're going to start this whole entire series. I think it's going to be awesome, so that will be very entertaining. Hope you guys check it out. Email. Okay, I'm trying to check out my emails. I'm trying to catch up currently. So, all right, cool. That's it. I have a debate with Karen B Saturday on Modern Day Debate. Of course, we have Flattoberfest coming up in October in Vegas. I do believe I will be speaking and giving a presentation, so you guys should check it out. If you've never been to an in-person event, what better one to go to? So definitely check that out. I think it's flattoberfest.com and flatearthfestivals.com. And that's about all I need to promote right now. So cool. A lot of stuff going. We got Audit NASA about to launch up. When I move to Florida, I will have a lot going on with that. So keep up with Audit NASA in the coming weeks. We should start getting stuff finally, like results. It'll be cool. I know it's been a while, but there's just a lot to it. And I've had a lot going on, but we also have that going on. And if anyone's interested in helping with the homeschool curriculum, I'm talking to a few people, moving some pieces around to try to put something together right now. So like based homeschool curriculum where we can help everyone out. So a lot on my plate, I'm trying to prioritize as I can, but right now, obviously getting the family in a new house in the right place and being able to find a way to afford it is priority. So word salad, brosif. And just so you guys know, word salad is defined as the incoherent ramblings typically associated with schizophrenia. So the phrases literally have to not make sense. If you disagree with them or you think that they're big words and don't understand them, that isn't word salad. But all right, cool. Thank you guys for kicking it. Sorry for like all the closing remarks, but there's that. And that's about it. Yeah, I do intend on getting on TikTok at some point. I just always forget, and I'm really busy. But okay, there you go. Thank you guys for kicking it. This has been Schooling Glovers, episode 19, Sunset. They do objectively work on a plane Earth. In fact, seemingly only on a plane Earth, and they work exactly how they would on a plane Earth. So, thank you guys for kicking it. Seek and speak truth unequivocally. Links to support the stream in the description. All are greatly appreciated. I will try to What's It Kicks It Sunday morning. Then we have Globebuster Sunday afternoon that I'll be hosting. So cool, yeah. All support is greatly appreciated in advance. Links are in the description. Seek and speak truth unequivocally. The weak find contentment in the consensus of ignorance. So whenever they revile you for speaking the truth's sake or for representing Yah, just rejoice. For they did it to all the prophets before you. What's popular is not true. What's true is rarely popular. I'll catch up with you guys hopefully Friday for In the Field. Peace.
Days of days, pseudoscience just a big charade, making theories they just can't explain, on philosophically biased claims. Days of days, we break away just like a renegade, so pay attention, gonna get a grade. We're schooling globers till they all awake. Schooling globers with diplomas and a chip on the shoulder. Debate is over, mind is sober, solar system disclosure. Can't go back once you heard the facts. We make a pact, never take the vax. Schooling ballers and the followers that give them the dollars. They try to holler in the chat that you're a fraud, not a scholar. They hating y'all, that's why they attack. The earth is flat no matter how much they laugh. Days of days, pseudoscience just a big charade, making theories they just can't explain, on philosophically biased claims. Days of days, we break away just like a renegade, so pay attention, gonna get a grade. We're schooling globers till they all awake.